In this screencast, we're going to talk about the second moments of inertia. And the idea actually is related to kinetic energy. Kinetic energy, 1/2 mv squared, is an equation that's often derived in a physics class. We're not going to take the time to derive this equation today. We're just going to use it. But the idea is if you have an object in motion of mass m and moving at speed v, then its kinetic energy is found by using the equation 1/2 mv squared. When an object is actually rotating, then the same equation works, but we can rewrite kinetic energy in terms of its angular velocity. So when something starts spinning, we're going to take something and we will spin it about an axis. Then that object has kinetic energy. If we assume that the angular velocity is constant, angular velocity is constant, the angular velocity with a change in theta with respect to time is constant, then we're going to develop a formula which helps us understand how to understand kinetic energy in terms of angular velocity. In the end, we'll end up with a moment of inertia. So the idea is as you move something around, you have a radius, and the distance traveled is the radius times the angle traversed. So if you want to take a derivative with respect to t, you end up getting r, that radius, is going to be constant as you move something around. So the r will stay the same, and then I'll have a d theta dt. Here's our angular velocity. Oftentimes angular velocity is denoted with an omega. And ds dt is our speed. That's from the t and b frame unit. So I have the equation, the speed is r omega. I'm now going to put that back up over here in the kinetic energy equation. So kinetic energy is 1/2 m, and the speed is now r omega, so r omega squared. So that gives me 1/2 m r squared omega squared. And that is the kinetic energy. It's actually the kinetic energy if I assume I have a point of mass m at radius r that I'm rotating around. When I take an actual object that has a mass, or an object of some mass, it's not actually all at the same radius. If I cut the object up into a bunch of little bits, each little bit has a different radius, and each little bit may have a different amount of mass. So a little bit of kinetic energy is found by taking 1/2, finding the mass of that little bit. So I've got an object and I've cut it up into a few pieces, and I'm now finding the mass of this little bit. I also need to know the radius of that little bit, so I have a radius and then an omega squared. The angular velocity is going to be the same regardless of which piece I pick, but the velocity will change. And the points that are further out will have a bigger velocity. This can be written as 1/2, the omega is going to stay the same, and then I'm going to write the radius and then the dm at the end. This is how you get a little bit of kinetic energy. So if you want total kinetic energy, you integrate little bits of kinetic energy, which means you integrate this term. If I pull the constants out, then I'm left with 1/2 omega squared, radius squared, dm. This term right here is called a moment of inertia. The moment of inertia is take the radius of rotation, square it, and multiply by dm. We're now going to look at an example, and the example we'll use is let's take a parabolic arc, t squared. Let's go from -1 is less than or equal to t, less than or equal to 2, so we're essentially taking that part of an arc from -1 up to 2, and that height's a 4. We're going to take that arc, and let's rotate the arc around. Let's start by rotating it around the x-axis. So if I want to rotate it around the x-axis, the radius is y. So the moment of inertia about the x-axis has a radius of y. So I integrate along the curve, take the radius, square it, dm. Well, in order to get dm, recall a little bit of mass is your density times arc length, which is your density times r prime dt. I need to find r prime. I also need a density, and we never picked a density here, so let's pick a density function. Normally they're given to you. I'll just write one down. Suppose the density is given as x squared plus 3y. That's a function that you'll be given in the problems. So I need r prime, and I need the density. So r prime is 1, 2t, and the magnitude of r prime is 1 plus 4t squared, square rooted. So I can now integrate c y squared, the density, x squared plus 3y. I need my r prime, 1 plus 4t squared. And then I need a dt. I now need to put everything in terms of t. So here's my x value, there's my y value. So this is integrating. Now I can put in bounds, negative 1 to 2. Y is t squared. X is t. Y is t squared. 1 plus 4t squared dt. And that right there is my moment of inertia about the x-axis. If I'd like the moment of inertia about the y-axis, well, if I'm going to go about the y-axis, the radius is now x. So here my radius is x, so I integrate c, x squared dm. Should be identical, except that the y value should be replaced with an x. So the y needs to be replaced with an x, which means rather than putting in a t squared, I should put in a t. And so the integral is identical, except I put an x in here now. And then this part stays the same, plus 3t squared, square root of 1 plus 4t squared dt. That takes care of what if I rotate about the x-axis, the y-axis. Now, what if I decide to rotate about the origin? And I want to rotate the object so that I'm just spinning it in circles. Well, in that case, the radius, if I pick a point on the curve, then the radius to the origin is, well, I need the x value and I need the y value, and that radius is the square root of x squared plus y squared. So here, if I'm going to find the moment of inertia about the origin, my radius is the square root of x squared plus y squared. So I integrate the square root of x squared plus y squared, squared, dm. The squared and the square root cancel. And now all I have to do is take the x value and square it. So the x value is t, I'll square that. Then I take the y value, t squared. The y value is t squared, and square it. That takes care of my x squared plus y squared. Now I need my dm. This right here is dm. So I repeat the t squared plus 3 t squared, square root of 1 plus 4t squared dt. And that completes this webcast.